Hi friends, welcome to the session on data analytics, the prerequisites for studying data analytics. I'm Dr. Sandeep, your mentor, welcoming you to this introductory prerequisite course. So what are the prerequisites? So the major prerequisite for any learning is an urge to learn. Yes, of course, we require an analytical thinking. That means whenever something is put forth before you, you should have some analytical thinking and you keep asking, what is this? Why is this? How did it come? Where it's useful? Why it is useful? Why not useful? All such questions should bombard your mind and you should have an urge to find answers to all these questions. Then some elementary basic mathematics is required, like calculus. Yeah, may look very boring or difficult, but if you look at from the application point of view, I don't think calculus is a tough one to hate or something. That's a most interesting thing. And of course, this course will ensure you how calculus can be enjoyed while applying to the real world situations. And then when we are dealing with a bigger problems, so definitely it would be advisable instead of working on raw level, let's get a little at a higher abstraction. So for moving ourselves to higher abstraction and working at higher abstraction so that bigger problems can be solved with ease. Yes, we do require linear algebra. Linear algebra, again, is part of mathematics, and if you feel mathematics is a tough one, of course not. Is one which is uh, made available to us to simplify our lives. Mathematics is one which is made available to us to simplify our lives, and because of mathematics, so much of things are being done. And one proof is that you are able to attend this course, which talks about data science, data analytics, and all that. That means it is talking about a situation where millions or billions of data are available. And millions and billions of data, when you are working with, definitely it is counting the number, finding the average, or finding the difference between numbers, or which is bigger, which is smaller. So at number level definitely is not going to make any sense and it is impossible to work. Therefore we need some higher abstraction to work with it, so that even though we have millions of billions of data with us, it would be definitely helpful if we can convert this into some few handful number of numbers, so that these can further be used for processing, understanding, many more. Yes, then comes probability and statistics. Because nothing in the world can be told 100% deterministically. So we need to speak everything in probabilistic language, because nothing can be predicted perfectly. So we can predict only in percentile. So what is the percentage of something happening tomorrow? What is the probability of this particular share value rising or falling, and all that? So everything we need to speak in terms of probabilities, and when you are speaking things in terms of probabilities, then statistics come to your aid and make the things more simpler. So we need probability and statistics further to simplify the problem. Calculus is the one which simplifies our problem. Linear algebra is used to further simplify the problem. Probability statistics are made available even to simplify further. Yes, you are dealing with machines because we can't do anything manually. Therefore, it's better we must have some programming skills without which it is not possible to continue. So in the programming skills, it's the best thing to have is basic skills, and basic skills are sufficient. So looking at analytics, so we have analytics, and one side we need a curiosity to learn, the other side we have problem solving capabilities, we need insights of storytelling, and then we need analytical thinking. So whenever you are trying to solve any problem, whenever the data is available or trying to analyze the situation, then first thing is you should have curiosity. Then once you have curiosity, then you need to have some analytical thinking required for doing further activities. Then you need some problem solving skills, and you definitely require the insights, and then you should have some storytelling capabilities. Urge to learn. The capacity to learn is a gift, ability to learn is a skill, and willingness to learn is a choice. That's what Brain Herbert said. So the capacity to learn, everybody is gifted with the capacity to learn, and the more skills you develop, the better, the more ability you will have to learn. For all of that, there is a choice. Are you willing to learn or not? So the first thing required is willing to learn, then use learning capacity and improve the learning skills, and through which again learning capacity can further be increased. So yes, you need to invest in your learning. At the age of 87, Michelangelo says still I am learning. Yeah, that's you will never stop learning. Every day is a new day. So we need to keep learning. So you just can't say that I have finished my school and I don't need to learn anything. You know, it's not possible. Till the last breath, we need to keep learning, and that's it. So the analytical thinking, if you look at it, it's somewhere related with the brain activity. So on the front side we have cortical, on the back side we have limbic, and the left brain, the left half, right half. And if you see that there are totally four parts you can have: front left, front right, back left, back right. The front left is analytical. So here a logical, analytical, based on facts, quantitative. Front right is imaginative. So that's holistic, integrating, intuitive, synthesizing. These activities are taken in this front right part of the brain. Backside left, it's something to do with well organized activity, well planned activity, sequential activity, detailed activities. All of them are taken care by this part of the brain, whereas the right back side of the brain is something to do with impersonal, something to do with emotions, feelings, aesthetic, and all such issues. So where are we? So we are more at front left side. That's a logical, analytical. This is based on facts. It is more quantitative. So we are working on analytical thinking. It involves an approach to thinking that allows you to break down complex problems into simple and manageable components. Analytical thinking is visual thinking that gives one the ability to solve problems quickly and effectively. Analytical thinking, you can just look at logical, objective, sequential, rational, focused, deductive, linear, convergent, systematic. So many objectives you can put it on that. When it comes to analytical thinking, it is logical. It has got some object. It works sequentially. That's rational. It's focused onto some particular topic. It is deductive, that means you can deduce something out of it. It is linear, it is convergent. Finally, it's getting into some focal point, then it's done very systematically. Five types of analytical skills are required for learning anything. The first one is communication, then we require creativity, then we require critical thinking, and then we need data analytics, and finally we require uh, research. Mathematics, of course, is a backbone of every high level activity, so it's essential. So many components of mathematics are there. Yeah, we can just look at the whole mathematics as a tree. On the bottom, we have logic, then becomes set theory, then number systems, then we have algebra, geometry, analysis, linear algebra, graph theory, topology. So one connected to other. So there are so many branches, sub branches, and all that. So we need to look at each one in detail, and then see how they are useful for our data science, machine learning, and artificial intelligence world. Calculus, yes, of course, is one of the most important aspects. So it's something to do with what happens when something changes. So you are trying to connect one variable with other variable, and you are trying to understand how one variable changes with change in other variable and all that. So that's where derivatives come into picture. And when you are trying to uh, add up the things which are not easier to add, then the integrals come to our aid. So more details will be coming. Just I'm giving a overview of what it is. So that's a derivative. That's an integral. So we are just using derivatives, so finding the slope. It's uphill, downhill, horizontal, vertical. So these are represented in numbers. Yeah, it's qualitatively we know what uphill is, what downhill is, what vertical is, what horizontal is. But when you want to put that in numbers, derivatives come to our aid. Uphill is one which has got a positive slope. Downhill is one which has a negative slope. Horizontal is a zero slope, and vertical is infinite slope. Yeah, some issues to discuss. Then we come to linear algebra. The linear algebra comes with many forms of it. It can be a scalar, it can be a vector, it can be a matrix, it can be a tensor. So with more and more complex system, we evolve linear algebra to a more and more complex. So if you are working with simple numbers, so its scalars are sufficient. and if you are working with a little planar activity, then vectors and matrices come into picture. When you're working into multi-dimensional system, then tensors come into picture, and they make our lives computation simple. And uh, this will be further helpful in coding, because if we work using linear algebra, coding also becomes very simple. Looping and all that will have very standard forms. Therefore, you can just perform them as some known way. So that's one way of solving a problem. So there is a unknown vector, there are coefficient matrix, there is a resultant vector. So we are interested in knowing. So this is something to do with solving simultaneous equations. So you can do the way we were doing in our school, solving simultaneous equations. So you take two equations, somehow manage to remove one coefficient or one variable, so that way continue doing it and reduce to single variable. We get answer to that, and then that answer you substitute into equation which had two variables, one of them just calculated, other one is unknown, so you can compute that. So that way we go back. So that's one option. The other option is directly work with linear algebra techniques and then directly find out solutions. Probability statistics is the other world where the whole situation is unknown all the time. Only part of the situation is known. So with the part of situation, if you are trying to guess what the whole is, then definitely the deterministic way of working will never solve the problem. So we need to go into probability and statistics. So probability statistics is a science where we take a sample of data from the population and we work on the sample. A handful of data we collect from the infinitely large population of data, and on this data we do some experiments and tell probabilistically that the whole population may look like this. So you can't say it looks like this, you can only say that it may look like this, because we are not working on the whole population, we are working only on the data which is part of it. So you collect samples from the population, a handful samples on which you can definitely do analysis. So this is called exploratory data analysis, and this will provide us probability of the different details, and these are used to infer what the whole population may be. So there are time dependent, time independent. So if you are talking about time dependent and time independent, then we have direct or objective, that is sharp one. Inverse is subjective, which is diffused one. So if you are talking about a time independent direct method, then we are working with probability. Time independent inverse method, we are working on statistics. And time dependent direct, then we are working on random process. Time dependent inverse, we are working on estimation theory. So there are totally four ways of solving any problem, whether the problem is time independent or time dependent, whether the problem is time independent or time dependent, and depending on that we are going to work on that. So totally we use linear algebra for probability statistics, and that in turn used for deep learning. Linear algebra used for optimization, and that is used with deep learning. So next we look at what we have in our programming requirement.